Hope you're all well. How many people do we have here today? We've got 66. How exciting. Um, Today's lecture is, at least my part of it, is something that is relatively straightforward, realistically. So if you're feeling tired from this morning, because this morning is the harder part, then you'll have a bit of an easier time. And if you kind of have missed this, I wouldn't stress too much because you can figure a lot of it out yourself. I did get a great question to start, though. Which is from ArtSmart, where ArtSmart says, where should we be up to at least for iteration 2 by now? I might just start with that question because I guess that's a very topical question. And it's a really hard question to give an answer to as well because every group works in a different way and how you work. Did I say afternoon? I don't know. Sorry if I said afternoon. Good evening. Yeah, like if we kind of look through iteration 2, I mean, most of the iteration 1 stuff you should have gotten done. Messaging and DM is kind of like if you think about iteration 2, I had a few students mention I had a couple of students say, why do we only have 3 weeks? Because last year we had 4. Last year we did 4 weeks for iteration 2 and 2 weeks for iteration 3, but iteration 2 was much bigger too. We've actually taken stuff out, so it's smaller now proportionally. But if you think about iteration 2, in the simplest sense, you have a whole bunch of messages. You have it like a DM creation stuff, which is like channel creation. So it's like you've kind of got all this management of channels and management of DMs. You've got all these messages with channels and messages with DMs. And then you got some user modification stuff. And, that's like the crux of the big parts of it, right? Now, where should you be up to? It depends where your group's saying. Well, all I would say is that if it's the end of week 5, if you don't feel like you have a grip on the DMs and the messages and the channels, or like when I say grip, I mean you're like halfway into it at least. Like you feel like you know what you have to do, you just haven't done it yet. Then I'd probably recommend you try and do that soon and definitely get that done by this weekend, because the thing about iteration 2 and the way it's designed is such that a lot of these components are somewhat interconnected. So it really encourages group work, and if you leave it till the last minute, it's very hard for like 4 people to get on it. So I'd say as long as you feel like you've split up work and you're all starting on different things and you've started making progress there, you're probably going okay if you're at that point like this weekend. Naturally, like obviously further's better, but again, it depends how much work you're doing with like how much work you're doing in Flex Week, because different groups do different amounts of work in Flex Week, so it's hard to tell. Anyway, let's get on to today. Today we're talking about WebCMS3 so fast. We're going to be talking about persistence today. It's a bit of a theoretical topic, and then we dig a little bit into how to work with it on the project. We'll see if we have enough time for a teamwork Thursday at the end. So we'll just do like 5-ish minutes of theory, be pretty quick, pretty high level. Then we'll do some examples with the Flask server to demonstrate what we're talking about. Also, I think my MBN is coming today. How exciting. Okay, so persistence. What's going on with this persistence topic? Well, many of you might have figured this out already because it's actually not like the most confusing thing in the world. It's just saving some files. But before we get into the practical elements, let's talk about like data and how critical it is to nearly all software systems. So we'll talk about data, we'll talk about persistence, then we'll talk about it within the context of your project. So firstly, the formal definition of data, well, there'd be a bunch of them, but in this case, facts that can be recorded and have implicit meaning. So typically, the way we talk about data is that data is just stuff you store, and information is insights you derive from it. And you use those insights to make decisions. So in a typical organization, data might be like just, raw stuff you collect in Excel spreadsheets or databases. Insights might be what you can extract from it, such as, average login times and stuff, and then decisions are what you then use that for. Now, this isn't a course on data. I mentioned here that data in big courses are becoming huge topics in the world of computing, though we don't address that in this course. You start seeing more and more things on data, like UNSW has a Bachelor of Data Science now, and there's kind of more and more topics focused on data. It will become a big part of most of your work in some way. You kind of have three ends of work. You've got this end of work where no one cares about data, another end of the work where you're working at Netflix or something, and like probably half of what they do is just data and crunching numbers and machine learning and looking at load times and view times and trying to figure everything out. And then you've got your middle tier, which is most people, which is people just working away at companies looking at analytics and data on like, okay, well, how's this working? Are people actually using this feature? How many times did they log in today, etc.? So there's a big spectrum of how you interact with this, but it's probably going to touch you in some way. Now, when it comes to most applications you interact with, data is a tricky word to deal with because data's everywhere, right? Like variables are data. Like everything is data. Like your program requires data to run. It requires memory. But when we talk about broader applications, typically the kind of language we're using is that when we say we're talking about our data, we're talking about some kind of data layer, right? And a data layer is just a part of your program that essentially stores data and has what we would call state. And what I mean by state is that if something has state, it means that sorry, the stream quality is dropping. If it has state, it means that it kind of stays that way, like quite literally just stays that way. Maybe you come back to it later and it still looks like that. And you kind of are familiar with this on your computer, right? In terms of, you open a Word document and, you interact with it and you're playing around with the interface and it's got all this stuff running in the background. And then when you hit save or it auto saves, it kind of actually, puts it on your hard drive somewhere. Okay, and that act of putting it on your hard drive is giving it state. You turn your computer off, you turn your computer on, you log out, you log in, it's still there. That's the data layer. It's where we store stuff. There's no way to simplify computer systems because they all differ. But one of the simplest ways to start getting you thinking about the different layers of a computer system is that you'll often have some kind of interface layer, which is the layer you interact with. Like if you're using YouTube right now to watch this, it's like that's the web page itself. You've got another layer underneath that typically might sit, somewhere on your computer or somewhere on a server, which is like the business logic layer. That's a lot of the code you write. And if you think about your project, it's like the interface layers, all the HTTP stuff. The business logic stuff's where you do all your like, oh, got to check if the email's valid, got to add this to my channels list. We call it business logic because it's logic you write specific to the problem you're solving. Underneath that, we tend to have kind of services a lot of the time. Things like your JWT libraries, things like your Json libraries, maybe some other things you write. They're kind of things that are more generic and, tend to solve a particular problem. Like this is the database service. This is the network service. Big companies will kind of write all of their own. Most of the time, the only way you interact with this stuff is through libraries. And then either underneath or beside that, you'll tend to have your data layer, which none of you really have. Like you have this data store. And I guess you could call that a data layer. You just call it a stateless data layer because it doesn't save anything at the moment, unless you've already done that. But that's one of the reasons why we also gave you a data store in the project, is to kind of get you in the idea that, a lot of systems will actually just have a layer that just is focused on the storing of data. So when it comes to this data layer, which you'll often hear referred to as databases, there are tons of different ways that databases exist as, sometimes we have in-memory databases. That's exactly what you're doing. Granted, it's a very crude, when I say you're doing, I mean currently to date. That's a very crude example of what an in-memory database is. Typically, real ones will, you can look up, is it Redis? I've never pronounced it. Like Redis databases, or they're like in-memory databases, so they kind of only exist in memory. You also have in-file stuff, like saving stuff to your system. That's what we're going to be doing in this course, because it's a nice little compromise between things being saved and being easy. And then you have like actual proper database stuff like relational SQL or NoSQL. Now, we don't really cover in fact, we don't really cover much of this at all in this course, but if you're more interested in like the proper stuff, you can go and like study COMP1531, because there's a lot of detail on it in that course. As you move down the list, the performance gets better. Often what you can do with it gets cooler, though, it's also harder to implement, or the barrier to entry becomes higher. I mentioned that in-memory is non-persistent, but we didn't actually explain what persistence is. So persistence is an idea where a program state outlives the process that created it. Typically that's achieved through storing the state somewhere in computer data storage. So this makes sense, right? You start your data server, you start your server, your Python Flask server, and you do stuff. You register, you create a channel, and data's stored on that server, but it's only for the life of the server. Once you kill that process, once you control C on the terminal on that Flask server, it's all gone. So even though the data's there, and even though it's being stored, it's not what we would call persistent because it's tied to the lifetime of the program that's running it. So, you know, again, if someone's like, are you storing data? I would say, yeah. I mean, I probably wouldn't. But, you know, you could say, yeah. Yeah, I'm storing data in my server, but it's not persistent. It's not persisting beyond the life of the, you know, the program. Now, this term can be used pretty broadly, so I'm having a very narrow definition of it to make sense. But in this course, we're referring to it as being like stored on disk, as you know, just stored on the file system. So the real question is, can we modify our project server to persistently store data? How would we do that? Well, let's have a look at some code examples. I'm pretty sure I originally was going to show you two methods. Ooh, VLab looks slow. So, I mean, maybe I won't show it to you too explicitly, but oh, VLab, please. It's not liking me today. But yeah, Izzy, no MBN. No, MBN got delayed by 2. So back in week 3, I said I'd have it, and then they turned up and they said, no, we'll come back in 2 weeks. And now they're meant to come this afternoon. So pray for me. All right, VLab, you win. Good old VLab. So there are 2 ways that you can kind of store data on your server. I'm going to show you kind of a more generic way with Json because that's something that you can apply to kind of other programming languages. But I'll also show you a slightly more specific way with Python, which is to do with a Python library that's essentially a serialization library. It's a very broad one, which is pretty cool. All right, well, sorry, didn't expect VLab to freeze up. Or maybe I'll show you the other way around. We'll figure it out. We'll show you one of the 2 ways. So I've got a point library here, and I got a persistent library. Nah, that's to do with the picklet stuff. Well, actually, let's look at the picklet stuff first. So here's how we're going to go through it. Last week, in a pre-recorded lecture, I showed you how we can play around with JSON. I gave you an example of how we can save an object to JSON, and we can decode the object to JSON. And I'll actually even just show you this here, right? Because we'll just do a really quick 60-second refresher. I was like, if you have a data structure like this, and you say Python 3 picklet, if you say Python 3 picklet, it'll take that data structure, it'll open a file, export.json, it'll write to that file, and it'll dump it in that file. And you will end up with a file called export.json. And that'll be it there. There's all the stuff. Now we got that. We also got that you could unpickle it as well, right? Like you could save that file, and then I could also write afterwards if I wanted to. I could also just totally reopen that file. And then say json.load, load from my file, and say that my, you know, new data structure equals json.load, and then I could just print my new data structure like this. So that one has saved it to a file and reopened the file, right? So what's cool about this is you're like, all right, I get it. I can save JSON to a file and I can open it from a file. All right, how do we put that in the server and deal with saving? Well, that's another question, which we'll get to in a sec. But before we get into that, there's a more specific method in Python that you can use to actually save and load up content from a file. And that's using a library in Python called pickle. I always do that. Python pickle. Pickle is a library in Python that's about object serialization. Now, here's the simplest thing to explain. With JSON, it's constrained by the data types it can represent. Now, this is a good thing because remember when we talked about object transfers and standard interfaces, because JSON is just strings, numbers, booleans, or something like that, because it's so simple, everyone understands it. But like a problem with JSON, as we talked about previously, is if you wanted to have another thing like date here, and then have datetime.datetime.now, you want to store the current date when this is run or something. This won't work because this data type is like, who knows, whatever, right? To get around that, there's a Python library called pickle, and what it does is it basically is able to serializes in basically take objects and turn them into like a string. It's able to do that for not just like strings and numbers, but actually all Python objects. It's kind of like I refer to it as, it's like a zip program, like a .zip program for Python, where you can zip up data of any type. You can zip up objects and stuff. The difference is also that it's encoded. It's not actually in string format. It's in a kind of binary format, but we can actually try this out here. So instead of using JSON, let's actually use pickle. And what I'm going to do here is instead of json.dump, I'll use json. Well, let's just start with the exporting part. And a common way that we refer to pickle files is with .p for .pickle. Now, if I try and run this, it'll mostly work, but there's one problem, which is that pickle writes in bytes. Now, that's like a weird concept, but the point is that it's just not writing in strings. It's kind of like when you GCC a program, right? Like, if I have like a.c and I have like an int main program here, and we return 2, and I compile this, right? GCC a.c. What we get left with here, if we open up a.out, is a whole bunch of binary. It's stuff. This is binary that your editor is trying to interpret as a string, which is why it's all gobbledygook. But it means something to a computer. And similarly, when you pickle something, it also turns into a kind of non-string format. So when you try and open a file, typically it wants to do it as a string, but with pickle you need to open it not just with the write property, but also with the bytes. I think it's bytes. I don't know if it's bytes or binary. Let me check. Open file Python. Someone will probably know before I can look it up. Binary. Okay, yeah, it's binary. So T's for text, which is default. So yeah, so text is in string. So B's the other option, which is binary. So it outputs it in binary. And in this case here, if I now run Python 3, pickle it, we're going to get a file called export.p. You see it appears here. Now this file looks like it's more readable than what was happening. Well, I mean, what happened with the C program was that's a bit more that's just machine code. This one's actual kind of binary that in this case my text editor's tried to open. I wonder what happens if I open it in no, it's all the same. Sorry. Yeah, it's all just binary. My bad. Sorry, I confused myself there. So, that's the output of your C program that will, run on the computer. This is the output of the pickle thing here. Now, the cool thing about this is you notice that I actually managed to pickle my datetime.datetime now, and if we try and reopen that, right, let's actually open my export.p and save it with pickle.load. You'll actually see it will actually print out my data structure. Mostly, I have to open it with B again because it needs to be a binary open. There's my datetime. I can actually modify that too. I can actually say new data structure date dot, I don't know, year equals 9. Is this how you work with dates? I don't remember off the top of my head. I'm just making this one up. Yeah, it's not letting me write to it, but you can do stuff with it. Like you can modify it. It's like this crazy way to just take like code you're working on and just like turn it into a package and store it on the system and then reopen it later. Now you can see here that there's a really important note in the pickle library which I just feel responsible to point out. Warning, the pickle is not secure. The pickle module is not secure. This is not a design problem with the pickle module. This is a philosophical reality of how you're storing stuff like this. Because if you can open something from a pickled file, someone could tamper with it and write any Python there. Right now, there's only so much danger someone could do with a JSON file. It's like, oh, they change your data. It's like, yeah, if they know the vulnerabilities in your source code, they could maybe change your data to deal with an exploitation or something. But with this, if you load something from Pickle, you could be loading in functions or all this other stuff as well. That because you could save functions. I can literally save functions to a Pickle file and open it up again, and then call those functions from a Pickle file. So it if your file system's compromised, then it really exposes what your program is doing. So that's why they kind of emphasize this quite a lot. Osama says, would the program raise an error if we use W instead of WB? Yeah, it would, because pickle.dump is expecting a binary stream on the file system to write to. It's just how it works. So it'll be like, it's just like, I expect a binary stream to a file. And that's how it works. Now, that's pickling. Thankfully, it's quite straightforward. That's what I mean. Like compared to some of the more complicated topics this morning, it's like, nope, you just use this library and it just, like the JSON stuff, it just dumps it to the system and you can open it again. Now, pickling should use pickling or should use JSON. That's really up to you. It doesn't really matter. If you're using classes or you're doing more complicated things, or you're storing your date times as objects, many of you will be interested in using pickle. Because, again, if you're doing more than strings and numbers, it has that benefit. If you are just doing strings and numbers, I'd probably recommend JSON, because JSON's easier to debug, because you can actually just look at the JSON file, right? You just open it and look at it. Whereas Pickle, it's like binary. So if I would kind of be like, let's use JSON until a time where we're trying to store objects natively, then let's maybe look at Pickle, because, we can do more with it. Is there a pickle.dumps? Yeah, there is a pickle.dumps. I don't know. Let me try it out. Let's just print it instead of saving it to a file. I don't know what use it would be, though. Oh, no file. Yeah. I mean, maybe if you were sending this over a network stream or something. There's probably no use for it if you're only intending to store it on disk. Yeah, there you go. Never tried that before. Okay, so let's quickly then talk about how you might actually use this in your server. So let's say I have this is a little example I made earlier. I might just talk to it rather than write it out for you, because you're all smart, you can figure it out. So let me just get rid of the pickle part for the moment and just have a look at the server as it stands. Oopsie, sorry. Now, you cannot worry about this get data thing here, because this is kind of like your data store file, right? I don't want to give you, I don't want to quite literally, like I'm trying not to quite literally use the exact same code as your project, because then I'm just being like, this is the code you copy, and you go, okay, and then you copy it. So just kind of imagine here, this is like your data store area, right? Normally this is in a separate file. Data store begin, data store end, or whatever. Okay, sure, and you have a route here, which is add, and what happens is that we decode request.json, we get the data from our data store, we append to our data list some kind of argument that's given to us, and then we print that back out and it's been saved in the data. So if I open up, say, Chromium here, ARC, and let's try this out. Let's go and run this server. So, Python 3, what was it? Persistent. So this server will run now. It'll be running on some port. You can't see it. It's on port 5000. So now if I go here and I go port 5000 slash, what was my route? It was a post and it was /add. So I go /add and then post. And then it wants something in the body. So my body is going to be application/JSON. And I'll use the visual editor. Why not? I don't like it, actually. Let's use the raw input. data is Hayden, like this. And if I click send, it should actually go and add it. Okay, so it worked, and it added it, and it returned me the list of the data. And if I call this again, it returns me, let me make this a little bigger, it returns me more data. So every time I'm doing this, it's actually adding more data, right? Just like your project. But if you stop the server and you restart it, it's all back to normal again. So this is the problem we're trying to tackle here. How do we add persistence to what we're doing? Well, the easiest way to do it is to think about persistence in two stages. When something happens on your server, you want to save some data. When you start your server, you want to load some data. Now, just to be really upfront, this is not in any way some kind of industry standard way to do this, because normally you'd be using proper data stuff. But this course is short, and you're not going to lose anything educationally if we give you this kind of little hacky way of approaching it. So that's why we do that, so we can spend more time on other things. So here's the approach we generally recommend on this front, is that you go and create yourself a save function. And what that save function is going to do, right, is that save function is just going to get your data as it stands, and it will try and, I am now going to save data. So let's have this function here, and what we're going to do is we're just going to put it at the end of every single route, which at the moment is just one route, but we'll put it here just before the return, you know, after you've done all your modifications and stuff. So I'll restart my server, and what you'll see is that when I run this, I might move my fat head for a bit. All right. When I run this, it says I'm now going to save Hayden. So I've inputted Hayden, that's what I got returned, but it says I'm going to go save it. I run it again. It says I'm now going to save Hayden. So you can see we're actually like ready to save the right thing, we just haven't saved it yet, but we know how to save stuff, right? We saw it before. I can go with open, I'll call this like database.json, write as file, json.dump, data file, done. So yep, let me just restart the server now. So you see something like this, JSON's not defined, classic. I think I was using pickle in this example. Okay, like that, click send. All right, now here's the interesting thing. Let's look at this database.json file we have. When I click send again, you can see that it actually gets updated. I have to click on the file to like make it update because the editor won't like auto refresh, right? But like if I then click, you know, send here, and I'm sitting on this file, every time I send it, it's actually adding something to this file. Now here's the problem. While I'm saving stuff, when I restart the server, the file still works there, but the second I click send again, it all disappears, because when the server started, it loaded up data with nothing in it, right? Because data was blank at the start. So now what we need to do is figure out a way how to load that in at the start. So I could say something like, you know, with open database.json read as file, json.load file. Yeah, and we'll say data equals json.load file. Now you might have to do some interesting work here in terms of exception catching and stuff, but we'll get to that. We're not going to get to that. I'm just going to leave that one with you, but let's just try this out as it stands. So we load this up, we click send, send, send. We look at our database.json, great. I stop my server, I restart my server, and I click send again, and now we have 5 things. And you could debug this yourself by actually putting something in here. Loaded data, like, you know, f string loaded data. I don't know if this will work. Will this work? I don't know how much it likes just printing. Yeah, loaded data. You can actually put it there so you can see what it loads when the server starts. Send, 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 send. Restart my server. Now all my data's there. So this is useful from a product experience standpoint, but also just from a debugging standpoint as well, which is why some groups have probably already jumped on it. Waleed says, in the project, it says we should periodically store our data in our persistent store. Does this mean anytime we make a change or literally any loop? Well, there's 2 ways you could go about that. You can either do what I'm doing here, where you put a save at the end of every function. That's just a little bit uglier and messier, though it might be more reliable. The other thing you can do is you can start looking into, like, you just Google Python timers, and you'll find pretty quickly that there are classes that will do, Python execute code every 1 second. I know you can't see that, but I wrote Python execute code every 1 second. Run a Python function every second. There you go. It'll run like this. But, you'll have to do a bit more digging into this approach if you want. You'll have to look at something like this here. You basically need to use a mix of like a threading library, which is essentially just how you can kind of run something asynchronously and play around with it. This one's a bit more fun. I'd personally nearly recommend doing this because it will be like you'll learn a little bit more about Python, and you'll think a little bit more about Python, and you'll need to use this kind of stuff anyway for your stand-up component of iteration 3, which we'll get to in a couple weeks. So I think this is a worthwhile route to go down. That being said, it doesn't really matter what you do. You can do either. You can either do this one, or you can do what I've done. We don't really care. We really don't, as long as it works. Periodically doesn't need to be consistently periodically. It can be like per route or something like this. Both of these approaches have problems, right? Both of them have problems. The route problem can expose itself to concurrency issues. The other one can expose itself to, you learn this, like, I guess, well, I don't think you learn this much at uni, but you'll figure this out kind of one day, right? Is that all these servers that are running and stuff, a lot of the time they're all running in parallel. They're capable of handling multiple requests at the same time, so there's like lots of things running at the same time. So if you have like 2 routes running at the same time because 2 people called it and they both try and save at the same time, one of them's going to make a mistake. There's a whole topic on, I think the closest you kind of get to kind of the challenges of concurrency might be in operating systems, which is a great course. But the point is they're both imperfect. They both have problems, but those problems will not manifest themselves in the scope of this course either, because what you're doing in this course is so relatively simple. That's it. That's the end of the persistence chat. We can have a teamwork Thursday now for those who want to stick around. I should really put up the feedback for today. This is just talking about Pickle. Here's the feedback for today as well, for persistence. So thank you all. With our 8 minutes left, we can do a teamwork Thursday. Let me find an old slide I made which had a few examples on it. But yeah, no, please fill in the feedback. Thank you. And I'll answer a couple questions quickly. How we tested on this, your tutor looks at your code. There's not going to be any explicit testing on this. Yeah, there's not going to be any automated testing on this. It's all your tutor looking at your code. I think there's a component we give them when they mark your code to, like, give them 5% for this or something. It falls into your code quality mark or something like that. It's relatively minor, but the thing is, most of you will want to do it for the easiness it will bring you, rather than for the marks, because it will make your debugging life a bit easier. And if you set it up correctly, if you want to reset the database, you should just be able to delete the database.json. The last kind of tip I'll give you all is add your database.json to the git ignore, or just don't commit it. You'll run into a whole bunch of problems if you all start committing any kind of database file, so don't do that. Would you load data every second as well? Not really, because the way it's kind of like happening is that you load the data from the file system at the start, and then it's in memory. It's in the data store, just like iteration 1. And then every time you do something, you're kind of saving it just in case Flask crashes. And then if Flask crashes, you just reopen it again. So it's a 99.9% hack method, basically. So yeah. Cool. Okay, cool.